we're going to prove the product rule, one of my favorite rules in calculus, probably my second favorite differentiation rule after the chain rule. Great rule. So this is a statement of the rule, just in case you forgot it. So it's that the derivative of the product of two functions, so f of x, g of x, is equal to one function times the derivative of the other one, plus the other function times the derivative of the first. And everyone uses it, but most people don't know how to prove it. So it's actually a very simple proof. It's not that rigorous at all. So first we're going to define a function called big F of x, which equals the product of the two functions. Now we're going to start taking limits of that function. So remember the definition of the derivative? When we do big F prime of x, that means we're doing the limit as h approaches 0 of big F x plus h minus f x over h. Remember, that's the definition of the derivative. And since we know what this is, we can do limit as h approaches 0. And remember what this is. This is f of x plus h, g of x plus h, minus f of x, g of x, all over h. And now we're going to use a little bit of algebraic manipulation to get our limits in order. So on the numerator, we're going to add and subtract a term of f of x plus h times g of x. So I'm going to do it down here. Equals limit as h approaches 0 of f of x plus h, g of x plus h, and then we're going to add and subtract the same term, which is going to be f of x plus h, g of x. That's the term we're going to add and subtract. We're going to subtract f of x plus h, g of x, and then we're going to subtract the term that's already there, f of x, g of x. And this is all over h. And I'm going to get a different piece of paper. I'm going to continue. So continuing our proof. Now we're going to group some of the like terms that we have. So we're going to go ahead and we're going to group we're going to do limit as h approaches 0 of, we're going to factor out an f of x plus h, and we're going to do the g of x. So we're going to do f of x plus h, and then we're going to have g of x plus h minus g of x over h. Okay, and we're going to put some brackets, and then we're going to have that all plus, and then other two terms, we're going to factor out the g of x, and after the g of x, we're going to have f of x plus h minus f of x over h. Notice we didn't change anything, we just factored out certain terms. So let's look at them side by side to make sure we're good. Okay, everyone good? And then we're just going to apply the limit rules as we can separate limits between sums and products. So we're going to do limit as h approaches 0 of f of x plus h, and multiply that by limit as h approaches 0 of g of x plus h minus g of x over h. We're going to add that to limit as h approaches 0 of g of x, and we're going to multiply that by limit as h approaches 0 of f of x plus h minus f of x, and you should be seeing what's happening at this point. So that's our final term. And limit as h approaches 0 of f of x plus h, this just goes to 0, so this goes to f of x. So f of x, this term right here is just the definition of the derivative for g prime x. So g prime x. This term right here doesn't even have h involved, so it's just g of x. And this term right here is the derivative for f prime x. And there you go. There's your product rule.